Hey everybody, Dinesh here. Welcome back to Tech Info. Today we're diving into the intriguing world of polar robots. You know how we always talk about robots taking over the world? Well, these robots took a look at the usual way of doing things and said, nah, we're going polar. We're going to break down what makes these robots so cool, from their unique design to their super specific applications. So buckle up, hit that subscribe button, and let's explore the future of circular motion. All right, so before we get into the nitty-gritty of polar robots, we got to understand how they see the world. And trust me, their worldview is a little different. Instead of the typical X and Y coordinates, these robots use something called polar coordinates. Imagine a robot chilling in the center of a giant dartboard. The distance from the robot to any point on the board, that's RR, the radial distance. Now picture a line going straight out from the robot. The angle between that line and any other line drawn to a point on the board, that's R theta, the angular displacement. So basically, instead of moving left, right, up and down, these robots are all about that spin and reach. Now that we've got the coordinate system down, let's talk shop about what makes a polar robot a polar robot. Picture this, a rotating base, kind of like a lazy Susan, but way cooler. On top of that base, you've got an arm, and this arm is where the magic happens. It can extend, retract, and even rotate at the wrist. This whole setup means polar robots can reach any point within their circular workspace with some serious precision. They're like the ninjas of the robot world, all about that smooth circular motion. Okay, so we've got a robot that moves like a graceful ballerina on a rotating platform. But how does it all work? Well, it's all thanks to these things called actuators, which are basically the muscles of our robot. We've got rotary actuators for that sweet rotation, and sometimes linear actuators for extending and retracting the arm. But the real MVP here is the control system. This brainy bit of tech takes those polar coordinates we talked about and translates them into commands for the actuators, making sure our robot hits all the right moves. Now you might be thinking, Dinesh, why go through all this polar coordinate hassle? Well, my friends, for certain tasks, it's all about simplicity and efficiency. Think about tasks that involve a lot of circular motion, like welding a circular seam or picking and placing objects on a rotating platform. Using a standard robot would require some seriously complex calculations to achieve that smooth circular motion. But with a polar robot, piece of cake, their whole design is based on circular motion, so the math is way simpler, and they can achieve that motion with incredible accuracy and speed. So, we've covered a lot of ground here, but let's recap why polar robots are so awesome. First off, they're the undisputed champs of rotational tasks. That circular workspace, their domain. They're also surprisingly simple in terms of their mechanical design, which means fewer parts, lower costs, and easier maintenance. Plus, their unique design gives them enhanced precision for certain movements, making them perfect for tasks requiring pinpoint accuracy. And last but not least, they're space savers. That compact footprint means they can squeeze into tighter workspaces where other robots wouldn't stand a chance. And that's a wrap on polar robots. Hopefully you guys found this as fascinating as I do. These robots might not be taking over the world in a blaze of laser beams, but they are revolutionizing industries with their unique design and capabilities. If you enjoyed this deep dive into the world of polar robots, give this video a big thumbs up and subscribe to Tech Info for more awesome robotic adventures. Until next time, keep those brains curious, and I'll catch you in the next one.